So this is a second video of the same lesson. So I'm going to go over a handful of examples here. We're given sine of A equals 5 over square root of 89. And that angle A is in quadrant 1. Find the exact cosine value in simplest radical form using a rational denominator. Okay? So my first step, again, in any one of these problems is draw it out. I know that it's in quadrant 1. So I'm going to draw out an angle in quadrant 1. Right, that's my quadrant 1. I'm going to pick a point, drop it down to my x-axis, perpendicular distance, and I have my triangle, right? So here I have sine of A. This is my A, degrees. And that's 5 over square root of 89. So that's going to be y over r. Okay, so in order for me to figure out cosine, I need my x value, right? So I'm going to use x squared plus y squared equals r squared, my Pythagorean theorem. So x squared plus 5 squared equals square root of 89 squared. So x squared is x squared plus 25 equals 89. Solving for x, 25 on both sides. So I have x squared equals 64. Square rooting both sides. I have x equals 8. Right? So then this is 8. Right? So my cosine value, cosine of A degrees is equal to, I don't know what, if A is in degrees or radians. I'm going to put A, 8 over square root of 89. Can we simplify 89? Or is that 89 a prime number? I'm leaning towards prime number, so I'm going to leave it like that. So to rationalize my denominator is that. Cool. Next one. Okay. Next one, we have this. And on your delta math, all you got to do is rotate, pick up this yellow point with your mouse, right? And rotate it 163 degrees. Okay, within 10 degrees. So you know 163 degrees will be in my second quadrant, right? So as you rotate that angle, this little thing will pop up. Okay, and it'll tell you like, hey, that's around, I should go a little more. That's around 163 degrees, and you just push some in. Yeah, it's within 10 degrees. So then if you go 173, you're still good. Or 153, you're still good. Okay, it's within 10 degrees. All right. Honestly, if you know what quadrant it's in, you should be good here. Actually, I'm going to take this time to cover the quadrants. Okay. So we know, erasing this. This is quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4, right? And if I have my coordinate as my X and my Y, I'm just going to put here, my X is always positive, my Y is always positive, and you know that your R is always positive, right? Okay, this will help you decipher your trig functions and their signs. Quadrant 2, my X is negative, my Y is positive, and my R is always positive. Quadrant 3, my X is negative, my Y is negative, and my R is always positive. Quadrant 4, we have positive X, negative Y, and my R is always positive. Okay? All right, and you can figure this out, but then I just gave you guys a little shortcut. All right? Cool, cool. Find the reference angle for a rotation of 210 degrees is our next example. So here, if I have 210 degrees in standard position, I would have standard position. So that's my initial side, positive x-axis. 210 is there, right? That would be 210 degrees. So what they're asking us is, hey, what is this angle here? What is that angle there? Because that would be my reference angle. What is it? 30. 30 degrees, right? So you just plop in 30 and submit answer. Okay. If you wanted to go a little bit step further, take my point, drop it down. We can figure out across the 30 is 1, across the 60 is square root of 3, across the 90 is 2, and then figure out my 6 trig functions there. Negative and negative, right? Because I'm in my quadrant 3. Okay. We can do that as well. Ooh. And what quadrant does theta lie in if the following statements are true? Tangent is greater than 0, so which means that it's positive. Sine is also positive, right? Greater than 0. Okay, so if that's the case, I'm going to draw out my graph and take one of these guys. Okay, tangent, or take the sine greater than 0. What quadrant is sine positive? 2, quadrant 2, and 4? 1, quadrant 1, right? So I know quadrant 3 and quadrant 4 is not the answer, right? So you can eliminate those. Among these two quadrants, quadrant 1 and quadrant 2, where is tangent positive? Tangent being y over x, right? So they both have to have the same signs, positive and positive or negative and negative. It has to be quadrant 1. Okay? So that's the answer there. All right. Moving on to my next example. How about this one? Tangent is negative and cosine is positive. Take one. Where is tangent negative? So since tangent, class, equals y over x, y and x has to have opposite signs, right? In order for that to be negative. What quadrants creates opposite signs for x and y? 2 and 4. So quadrant 2 and quadrant 4. Cosine being positive, cosine is x over r, and that needs to be positive, right? I know my r is always positive, so my x needs to be positive as well. So between these two guys, quadrant 2 and quadrant 4, where is my x positive? Huh? Quadrant 4. So that is my answer there. Okay? That makes sense? So taking one of these would eliminate two quadrants. And between the two, which one does that? Which out of the two would satisfy my other property? Okay. So again, I'm going to take one. Tangent is negative. Sine is negative. I'm going to take this one. Where's sine negative? Well, sine is y over r. R is always positive. So y has to be negative. Where is y negative? Three and four. Quadrant 3 and quadrant 4. Between those two, I need opposite signs because tangent needs to be negative. So it needs to be quadrant 4 because that's where my x is positive and my y is negative. Okay? Cool. Last one. Express the following as a function of a positive acute angle. They are just asking us to figure out the reference angle. Okay? So if I draw it out, (231) in standard position would be here. 231, that's 180. It'll be somewhere around here, right? That's 231 degrees. So what they want is this angle. What is that angle? What is that angle there? 51. So you just put, hey, this is the sine of 51 degrees. That's it. Okay. We all know this one would equal in quadrant 3, right? But then your answer just wants you to put sine of 51. Okay. And that is the notes for today. That is 6.3 on trigonometric functions of angles.